Yeah, see our online people who watching us from internet. I want to say big thank you to everyone who come to us today in Gdynia and who watching us, and of course to sponsors, to all people who preparing this meetup, Future Processing Company, Running Scopes community, and of course AWS. And I'm glad to say that our community is all time grow up and say to enjoy the new knowledge and of course new networking. Short agenda. Today we have 2 parts with short pizza break, and after that we have offline parts which without translation. It's Kahoot quiz with presents from our sponsors. Okay, and first our first speaker is Anton Brodziak. Sorry, Adam.
Okay. Hello, can you hear me? Yes. Hello, Gdynia and 3City. I came here from Silesia, so from Katowice, from the headquarters of Future Processing, which are like next city next to it, which is Gliwice. And I'm glad to see you, and my heart is rising because I see so many smiley faces. And we are going to talk about Kubernetes, as you can see from the slide. And that's going to be a story about how we've made the thing and why it is like that and how it happened. So, quick agenda. First, why we are here, so like introduction and the story. Then, what we have learned from the project. So, first couple of words about me. My name is Adam Brodziak, and I'm, like, as you can see, Linux nerd from 2007. I'm doing DevOps from 2009, which is like quite an interesting year because 2009 it was the year that DevOps as a term has been coined, and it was on a conference in Brussels, in Belgium, and I was then working in the Netherlands, in Den Haag specifically. So it was very close to Belgium. So I like to talk about myself that I've been hit by the first DevOps wave of adoption across the Europe. That sounds nice, but the reality was that we've been programmers, and the sysadmins either did not have time or skills to manage our servers, so we had to take care of that as well. And this is how we became DevOps effectively. So since 2014, I'm working at Future Processing, and that's like almost 9 years, which is for me like kind of scary. On the other hand, next year is going to be 10, and I'm going to get a cake because this is what you get when you reach like a 10 years at anniversary at Future Processing. And I'm blogging a bit about all the like DevOpsy things. So yeah, so we can check it out. And I'm Linux nerd, and this is quite important. Some Linux jokes might happen here. So if you enjoy, like, let me know. You can free to ask questions because this is like, it's not like a presentation to be recorded or anything like that. This is like a meetup. So we've met here in order to discuss some interesting things. So feel free to ask me questions. I'm talking about people who are obviously here because I don't have feedback unless like somebody will tell me questions at the end from online community. Yeah, I think that's the important bit. And the Linux nerd bit is important because in case this happens, I'm not sure if you know that meme from XKCD. I know the answer, so you are safe. It's not going to blow up, so stay with me. I will give you a second to read that. it's very like it's very old joke in Linux world. So I saw some smiles, so I hope it's funny. But to the gist of it. So a couple of years ago, actually 3 years ago, like my then boss asked, like actually head of technology, Szabel, because this is how we call them. It's not like Krzysztof, but it's Szabel by his nickname. So head of technology at Future Processing, we were in a meeting and like I was actually asking for promotion, and he asked like, okay, but you seem to know something about DevOps, and I see it is growing. I said, yes, yeah, I since 2009, I'm doing this. So maybe let's do something. And this is how basically DevOps business line has grown in Future Processing. So on one hand, you know, we've got like a 1,000 people company. On the other hand, we've got like 20-something people in this business line, and this gives us some kind of flexibility and this kind of startup atmosphere and this kind of integration around DevOps topics. And it's growing steadily since 2020, and we are learning and we are like exchanging ideas and we are mixing with each other, and we start to see patterns. So over time, especially in regards to Kubernetes and AWS and those kind of things, we started to see like the things are similar, and the team over there for this customer does pretty much the same over. They came up with the same ideas like the team up there. So that got me thinking, and I coined like basically a new term. You are familiar with infrastructure as code. Or who is familiar with what is infrastructure as code? Let me put it that way. Okay. So I coined new term. First, like the shortcut, the acronym. So maybe you've got an idea. What does it mean? I gave you a hint already. That's somehow related to infrastructure as code. Any ideas? Okay, process. Someone else? Programming? No. What? Pattern? No, it was. Think about that. It was related to what I was saying a bit earlier. That we saw various people doing essentially the same things. So what I call this is copy-paste. That's right. It's infrastructure as copy-paste. And this is what we discovered. So imagine like a couple of teams that are doing essentially the same thing over and over again. And it was like related to Kubernetes, to AWS infrastructure, and the likes. So we've solved those kind of problems. Infrastructure was the same. For example, on EKS, like everyone had to came up with the same problems and figure it out the same solutions. And observability, it was quite often an afterthought, but it was so much necessary that I'm going to talk about that a bit later. So what we were thinking is like, let's do Kubernetes well. And you can imagine, this is how Kubernetes Well-Done has been like established as a name. So this is essentially like a product that we are developing internally. I hope it's not heard in like this drilling there that is behind me. Okay, cool. So it's only drilling in my head. So, but I will try to manage with that. So this is basically a product that we are developing at Future Processing, and basically to avoid this kind of copy pasting the same configuration all over again, because it comes with many issues, not only like copy paste, but also like IP restrictions, so intellectual property or authority or authorization or whatever. And by this, we have basically those codified practices. So this is infrastructure as code, but not pasted anymore. We've got this observability stack, which is very important, and I'm going to talk about that because this basically validates the product works. And what is also like a nice benefit for our customers, we made some, let's say, clever choices about AWS setup where the costs are optimized. So, are you familiar with those tools like Terraform, Customize, and Bash? Who knows at least some of them? Okay, some hands are there. So we are going to talk about a little bit how we are using those. So Terraform has been chosen by because it's not my favorite. You will see in a second why. But it was like the most common denominator, so to say. So basically, a lot of people, as we have seen here, knows Terraform. The configuration language is fairly simple, and it has got like providers for all of the clouds are there. So not only AWS, and that was like at the beginning quite important point, not to be like tied into AWS, even though we went with AWS at the beginning, but have option for other clouds as well. But that's something that happened literally last month. So long story short, Terraform has changed its license from, like, I think they were using Mozilla public license, and now they use this BSL, so business source license. And our product is essentially vulnerable to that. So this is one of the things that I wanted to share with you. What kind of problems you are going to face when you try to build product. So right now, this is a problem for us, that we essentially ship Terraform and they change the license. So we either have to, and that's not like legal advice, so we are just thinking, and I'm thinking out loud here, either like ship Terraform still and pay the license fees according to this BSL license, or maybe switch to OpenTF, maybe, or maybe do something else. Because this is how I feel after working like over 2 years with CDK, so AWS CDK, and getting back to Terraform. It's like, I'm not sure if you recognize non-English, non-Polish speakers. It's like, geez, how do you live here? And this is how I was when I got back to Terraform. It was like, really? This is how things are done? So, do you know do you know CDK? So AWS CDK, how it works? Okay, few people know. So I not necessarily recommend going Terraform right now. Better stick with CDK. However, CDK also has its own problems. I myself contributed like a bug fix and a feature to CDK myself, because this is like, it's far from ready. That's one hand, and on the other hand, if you've got experience with EKS, so Elastic Kubernetes Service, and CDK, EKS feels like a second-class citizen inside CDK, and they've made some weird choices in CDK to handle Kubernetes, but that's maybe like for another time. I was tweeting about that furiously like 1 year ago or something, or maybe 1.5. So you can dig up my tweets about how bad Kubernetes is in CDK. Okay, but that's bashing CDK. That's enough. That's AWS sponsored event, so I should not say that. So let's go to next, which is Customize. And Customize was, in my opinion, quite easy choice, because It's like a way of handling the manifests. So people familiar with Kubernetes live with those manifests. Still, I don't know how, but somehow people manage. And what it gave us, for example, over Helm charts, was fast iteration. So it's easier to basically write an overlay and customize if you want to customize something, rather than like build a new version of Helm chart, release it, then pull it, then package, then pull, and then use this new option. So customize is much easier with that one. That's why, and it's like it's faster iteration in that way. So that's why we got with customize, and you can use overlays, so built-in mechanism to handle many cases. And it's not this full like continuous delivery or continuous deployment solution like Flux CD or Argo CD. So you've got more control and you've got more overview of how things are going. Because if you go, not sure, anyone who is familiar with Argo CD or Flux CD here? Okay, so you probably know that if you go with that route, you lose a little bit of control. So you basically do a git push and then you hope things will happen. But it's not always that way. And you don't know why. And with customize, the plain customize, you basically do kubectl apply with -k, which means customize, and it happens the same way like with kubectl apply, the plain one. All right. But it has got some drawbacks, and this is like, it's not all roses. The parameters passing is a bit painful, and that's why I added bash to the mix, because it somehow always happens in those infrastructure as code things. I never ever seen like a setup without any sprinkle of bash. It's, have you seen like a infrastructure as code setup where there was no bash? Anyone? No hand. Yeah, everywhere. So this is like very clever. Actually, it's not bash. Probably it's not bash function. This env subst, but it's something, I don't know how can I highlight. Yeah. Okay. But it's something that you can use to basically mix the parameters inside the YAML for customize. All right. And the next big topic and very important one is observability. So that was one of the most important decisions, in my opinion, for this Kubernetes Well-Done product, to build in observability. Because for me, it's like, it's a must-have, and it's also very important case to prove that it works. Because we are essentially building a cluster, a Kubernetes cluster in cloud, and how do you know that works? Any ideas? Yeah, basically you have to. Yeah, but there is no customers or no users yet. So it's you are just deploying for example, for yourself, for development environment or whatever. So you basically don't know. The only way is to observe the system. So basically, what you have to do is to deploy something and then see if that is working. And here comes the observability, because there is no other way than basically observe using, for example, kubectl logs or something else, if that is working, or kubectl, for example, get pods or something like that. But why use like such a crude and low-level tools if you can basically use some proper observability tool? So we went with something that looks good to me, because this is how normally this abbreviation is expanded. This one I'm talking, yeah. But this is basically a stack from Grafana. So it's like Loki, Grafana itself for the visualization. Loki is for logs. Tempo we haven't like employed yet because reasons I will explain later. And Mimir, this is like a. Do you know Prometheus? Okay, so this is like a Prometheus for scale. So if you need scalability Prometheus, this is the way to go. Yeah, basically this is the reason. So Prometheus metrics are standard, and they already happen to be deployed on many different configurations, but usually in a way that it's not highly available and it does not scale, and Mimir comes to the rescue for this specific thing. And the other thing that is very important is that it lets us keep costs at bay. So we've got some control over costs, and I'm going to talk about that a bit because I think this is extremely important in cloud environment. Because we are on AWS Meetup, right? So who likes to use AWS? Raise your hand. Okay, who likes to lower your hand? Who likes to pay a lot for AWS? I don't see any hands up, so I assume there is no Amazon shareholders here. Because if you would be Amazon shareholders, you would be happy to pay a lot for your customers to pay a lot for AWS. But I see no hands up, so no Amazon shareholders. That's fine. That means I can reveal some tricks. Because cloud cost is something that is delusional, in a sense that you think about costs for the cloud, but you don't think about the cost of observability. So who do you, like for you who are aware of the cloud spending, who is spending more on observability than on the application itself? Do you have an idea? Like, I'm definitely to blame for that. And I saw many teams who are in that situation because they wanted to have, pardon? Yeah, exactly. So you've got like application observability, whole application for observability, and probably it costs a lot to maintain, and the cloud costs and all of that. So we've seen that. I've seen that personally happening a lot. And we applied some things to basically mitigate that. Because storage is expensive, and for logs you've got a lot of storage, and for metrics too, but for logs it's even more like prominent, or in some cases you are legally bound to store, I don't know, for example, a year of logs. And for Loki you basically just write logs to S3. So this is like, because that's the dream, or that's the like definite answer. So how do you want to handle your logs? Do you want some kind of databases? Do you want some kind of like complicated system like Elasticsearch that you have to manage yourself? And it's not easy. I was talking about that this year at March, I think, on DevOps 3City meeting, where we've migrated from Elasticsearch log/Kibana to Loki, and how it helped to improve reliability and also reduce costs a lot. So for such as like trivial things as logs, you do not want to like have a database, especially clustered database like Elasticsearch. Who came up with that idea? It had to be Elasticsearch consultants who want to earn a lot of money. I don't see any other reason. So with Loki, you basically write to S3, and this is the reasonable choice, and this is the like how it should be. You just write to object storage, and then Loki takes care of retrieval and querying and how to handle that, and they do it in a clever way. That's again like for another talk. So storage cost is one thing. Yeah, but do you have an idea how much cheaper is S3 compared, for example, to EBS? So something that you would use for Elasticsearch, for example, for storing the same amount of data. Do you have an idea? We've got like AWS fans here. Yeah, but any idea how much? Yeah, it varies because I've heard like from few times, 10 times to up to 100. It depends which, for example, S3 version you use, the specific service, or which EBS, because there are also a couple of others. But it's like the nominal case, I think it's like few times or 10 times less expensive, S3 compared to like nominal case to GP2, I think, storage volume type. But then there is also compute costs, which for example, Elasticsearch, because this is what is like the popular alternative, let's say, and a beast to manage. Like Elasticsearch needs a lot of memory, like so give them like the biggest EC2 instances you can get, and like allocate all the memory to Elasticsearch, half of the memory to heap size and the other for page cache, and you might be fine. Because I still know cases for one of the projects we run inside Future Processing where even that was not fine. So seriously, they've got some serious issues with some percentage of queries. Sometime it is so slow that it's unbelievable. But they use it for like for critical path on the application, so it makes sense. So even it makes sense for them to overpay. So they are buying instances that are twice as big. But for logs, come on, it's like it shouldn't be like that. Why would anyone want to deal with those kind of Elasticsearch crazy things? And the other thing that you can use, for example, with Loki is, and as actually for the whole stack, because it is written in Go. Also, all of those things like Loki, Grafana, Tempo, and Mimir, they're all written in Go, so they compile to ARM code natively, and they compile well. Again, in contrary to, for example, Elasticsearch, which is running on JVM, and JVM has got unknown bugs on ARM, where I don't remember what was exactly the bug, but it makes some context switching painfully slow. And I know it from like first hand from a guy who actually discovered this bug, because he's working for Neo4j, so this like scalable, enormous graph database. And they've been hit by this problem on ARM quite heavily. And on top of that, like those nodes on ARM, they are up to 40% cheaper for the same amount of RAM, because this is something that stays the same. So you need also quite a lot, but not as much RAM for Loki, because Loki is not doing this reverse index. It only needs RAM for query. So still not as much, but the RAM is like the defining factor here. Okay. And let me ask you, do you know what happens when you run AWS services on default settings? That's right. This is what happens. Like Steve Bezos is more than happy for you to do so. Like he is the most happy person on earth when you migrate your old, clunky, slow application to cloud, because he makes a lot of money out of it. I know Jeff Bezos is not like the CEO of Amazon anymore, but this, like, I love that this Photoshop. And why is that happening? Actually not me. It was Ben Thompson from State Cherry. He calls this thing strategy tax. So strategy tax in big corporations is something like when they have to make a decision to do something, and like let's say there are two options. So if one option is that they are going to get more money, not for example from this, but from something else, they will go for it. So there is no such kind of thing like, optimization for the sake of optimization. It's like it's better not to do anything if that makes us more money. And for example, this is one of the cases where GP3 is there for a long time already. And GP2 is default. And I don't I don't understand why, because GP2 has got two drawbacks. One is obviously the price that you see, but the other drawback is that if you want to increase the throughput, so you want this volume to be faster, you have to increase the size, no matter if you need that. So the throughput and the performance and IOPS, so IOPS, so per second, yeah, thank you, increase only if you increase the size of the volume, and this is for GP2. For GP3, you can set up those things in a separate way. So there is one setting for size, there is one setting for IOPS, and another for throughput, which is like basically combination of those two. And only in this version of Kubernetes, you will get that by default. So up until this version, and this is what we have to code it, and this is what we've got in our like Kubernetes well-done code, is setting up GP3 for all of the persistent volume claims and all of the nodes. And like this was the code that we had to maintain, and hopefully soon we will not have to anymore. I hope so. I don't. This is already merged, but I'm not sure if that is released. Okay, so that's one of the things. The other thing is, in theory, you are getting EKS cluster, and what that actually means, if you click like to create a EKS cluster, is that AWS will get you control plane. So control plane in Kubernetes is like a set of services that manage basically the Kubernetes cluster itself. But you also have to get some nodes where you are going to deploy your workload, so your applications. And this is, as far as I remember, this is what you get by default. So again, like strategy tax. It makes sense to use large, because why not? Like, people will start those AKS clusters every now and then, and Amazon is going to make a lot of money. So what? Like, the shareholders are happy. I know few people who have like literally millions in like millions of currency in Amazon stocks, and they are so happy about that. But should we? Should our customers be? I don't think so. So that, because one of the decisions we made at the beginning also was to stick to EC2. So for EKS cluster, when you started on AWS, you have a choice to either go with Fargate or EC2. So for the portability reasons that I mentioned earlier, that eventually we will migrate this to Azure or some other clouds, we haven't got into Fargate. And the other reason, again, is costs, because for the same compute, it's more expensive to get it on Fargate than on EC2. But then you ask me, what about like the fit? So what about case where Fargate actually excels, so you are getting just that amount of RAM and that amount of CPU? Well, we've got an answer for that. Enter Carpenter. This is a solution from AWS, developed by them and deployed, and it's not deployed by default again, because strategy tax, because why they would bother deploying Carpenter on their own EKS clusters when they can make more money out of like standard cluster autoscaler? So who is familiar with cluster autoscaler, what it is? Okay, so I will explain briefly. So cluster autoscaler basically is a solution that is default in Kubernetes, and it works with many clouds, where if there are like, when it's configured, there are like unscheduled pods, that it will grow the cluster. So basically it will spin up new nodes, new compute nodes. And this is the like the very basic of how cluster autoscaler works. How it works on AWS is that cluster autoscaler, so the default one, what it does when it gets pods that are not scheduled on any node, it will modify the node group. We know what is node group, the EC2 node group that manages nodes. And then there is a delay, and then maybe AWS extends the node group and spins up new node. But you get like uniform nodes, so they are all the same. With Carpenter, it's a bit different because Carpenter does not use node groups at all. So it manages their own nodes. And what it will do is it will not like change some property on node group and then wait till some other process will pick it up and then spin up new server, but it immediately spins up new EC2 instance, an instance that is just the right size. So it will measure how big the pods are, the ones that are pending, that are not scheduled on any node because they don't fit, and they will like, and Carpenter will just spin up just the right the most reasonable instance, let's say. And there are like a couple of algorithms how to calculate the most reasonable, whether it's like CPU, memory, or anything in between. But there is less chicken and egg problem still with this Carpenter solution, because there is a Carpenter and there are nodes. So Carpenter is the chicken and nodes are the eggs. And in order to make eggs, you need a chicken. But Carpenter is just a pod, so it has to run somewhere. So basically, you still have to have, and this is like a drawback of our decision and our setup. You still have to have some kind of nodes. We don't know yet. Basically, we are still trying to figure it out whether it's going to be 1, 2, or 3, or how big they are going to be. But you have to have like a node to deploy Carpenter, basically. But it's not only Carpenter. It's also like a couple of other things like EBS driver, CNI driver, and a couple of other pods that have to be deployed on every EKS cluster, even though, again, AWS will not deploy them those drivers for you, because why they should? It's atrocious, to be honest. Yeah, it's this chicken and egg problem is like nothing new. It happens every now and then. All right. So as you can see, the title of this talk is Kubernetes Well-Done, but as you can see, it is like Kubernetes some done, I would say. So there is still work to do. There are still like things to figure it out. There is still like a lot of deployments to be made. So we are still working on that, and we basically need your help. So join us and like share the experience and help us build this product. Thanks. Thank you for your attention. Let's be in touch. Any questions? Wait a second. You will get microphone, so it's recorded.
Okay, so I was asking if in this setup where you deploy this logging stack with Grafana, so do you disable pushing logs to CloudWatch at all, or like running in parallel? Because I know that sometimes going through CloudWatch may be expensive as well.
Yeah, well, yes, but actually no. This is the best answer I can give you. And I'm going to explain why. Because CloudWatch is expensive. So we were talking about like Elasticsearch is expensive compared to Loki. So CloudWatch is yet another level. It's so much more expensive. I don't even know how much, but I know it's like tenfold or more. We are going to do calculations about that basically, because we are preparing like some marketing materials where, you know, business people want to have those kind of calculations. So they are going to, they will be coming. So follow me for on Twitter or on my blog. I will publish those calculations as well, because why keep for ourselves or only for customers? We want to make them public anyway. So we would like to avoid CloudWatch. However, there is important bit of the EKS cluster which is control plane, which we don't have control over because this is hosted by AWS. This is provided in a software as a service matter or platform as a service. So this is something that we have no control over, but we would like to monitor it. And the only option to monitor EKS control plane is through CloudWatch. So there is a special setting where you have to enable CloudWatch for control plane. But what we are doing is and there is also like a special Lambda for Loki, which takes this CloudWatch and ships it to Loki. So we've got very little retention for that to reduce costs, but we still have to enable that. Thank you. Does it answer your question? Excellent. Any other questions? Okay. Let's wait for the microphone.
Okay, sorry, perhaps I missed it, but you told that you decided to get rid of Tempo from LGTM stack. So
Yep.
why did you do that?
Okay, so Tempo is basically, again, like this kind of distributed storage for traces. And traces are a bit more involved on the application side. So basically you have to change your application in order for traces to have any meaning. So there is like a necessary component for the software development to be involved. However, for logs, you don't have to do that at all, because everything is captured. Whatever is sent to standard output and standard error inside Kubernetes, it is being captured by Loki and by Grafana agent specifically. Grafana agent is this component that wasn't on the slide, but is also quite an important part of our setup. Because Grafana agent is something that grabs logs, grabs metrics, and sends them to Loki and Grafana, Loki and Mimir respectively, and it also deals with traces, but I don't remember if it's like very early preview or it's beta, so it's not ready yet. So that's why. So those are the two reasons. One, it requires some changes on the application side, and we haven't figured out yet about the recommendations, what would be the best practice. And the second, Grafana agent that we use does not handle production grade tracing sending yet.
Okay, so it was LGM stack actually.
Yeah, that's right. Okay, any other question? Okay, I see another one. You've got very good questions. I'm impressed.
Okay, so maybe just going back to what you said about Terraform versus OpenTF. So you mentioned that you're using CDK, right, as a default one. Did I get it right?
No. So the product, so the Kubernetes Well-Done product is developed with Terraform right now.
Right.
Is that what I meant about CDK is that 2 years before starting that, I was developing in CDK, and then but we made like a deliberate decision to stick with Terraform. And when I saw Terraform after working with CDK, it was like as you saw. Yeah.
So I understood it like opaque.
Okay.
So the question is like, you know, this OpenTF is basically actually I think allowing us like as a community to build a better product in a way that Terraform has its flaws, right? But HashiCorp was guarding quite a lot there, and they were driving their way. And it's why are you as a future processing, are you actually considering giving back to community, actually spending some time on making it better? Is the question.
I don't know. I cannot answer that question because right now we are thinking about that, to be honest. We haven't made any kind of decision, so I don't want to like make a statement here that is going to be recorded.
Yeah,
on
sure.
top of that. And we haven't made a choice either way. So that, for example, the contributions that I mentioned to CDK, for example, that was my personal one, my personal
Right.
choice, because we are free to do so. But here that would like that's a bigger decision. I don't know yet. We can talk about that later when it's not recorded.
Maybe that this won't be a question truly, but regarding to the license of Terraform, we also facing this, let's say, issue or that change that happened last days, weeks. So currently in our project, we are using Terraform for building an internal platform for enterprise level. We are delivering landing zones for Azure Cloud and for AWS. It's plus, I guess, 30 subscriptions or 100 AWS accounts. We are also using Terraform for maintaining the connectivity by one of the third parties like Aviatrix, or configuring firewalls with FortiGate. So we are in the process of analyzing that, but so far as we read some statements from HashiCorp that using providers should be still available. So maybe that's the question. What do you think about that? I mean, from our understanding is that, let's say a third party is using a Terraform base code to build something on that, they would be affected by this license change, like TerraGrant or any other tools that so far they were using that license. So did you look at it from that perspective, only using a provider?
Okay. Personally, no, I haven't. As a company, we are looking into that, basically what to do with this kind of license change and fork and all of that. I haven't got time to be actually to be involved in this, and I don't like this kind of drama. And again, we can talk about more freely after when it's not recorded. But it's a problematic case, and it's like I understand where Terraform, actually HashiCorp, is coming from, and what they want to basically block. On the other hand, like I also understand the upset from the community and actually other because it's other companies that have benefited from Terraform. And building like sometimes better products on top of Terraform, and I also I'm puzzled why they choose this particular license, and for example not AGPL license, where it basically covers like creating paid product or paid service out of code. Is not basically allowed without the contribution back. So yeah, so I don't know. It's like a complicated matter. But we can talk later. So it's interesting discussion. Okay, any other question? Other than Terraform? I'm sorry.
I have a question if you can say a bit more about this Carpenter, because so far it seemed to me that node group is the only way to add some instances to the AKS cluster. What's the relation with AWS in this Carpenter? It uses like AWS API to add these instances somehow?
Yes, essentially that's what it does. It does not deal with node groups, so AWS node groups at all. It just adds like another instance. So essentially, I think it does what you are describing. So is using AWS API in order to spin up new instance, and the instance size is like measured and try to put in line with what is needed, rather than like spinning up another beefy instance, if no matter if it's needed or not. But it tries to measure what kind of pods are waiting in a queue to be scheduled, and then spins up using AWS API the right one, the right sized. Okay. It depends. So you can configure, for example, what kind of instance families and instance types you accept at all, for example, because you can limit that, and then it will try. There are a few algorithms that decide which one is the optimal, and it will can you repeat that to the microphone, maybe? Okay.
I'm not familiar with autoscaler either,
Okay.
but I think my feeling is that autoscaler just spins up instances from some configuration, maybe default, of one particular size.
Okay.
But Carpenter spins up instances choosing between different types and sizes, right?
Almost. So cluster autoscaler, actually what it does is not even spinning up instance, but it's like altering the property of node group. So it's changing the instance count of a node group, like incrementing it by 1 or 2 or maybe more. So it's operating on the node group concept inside AWS, and then there's another process that has to like scan that it happened, and then like it grows the same exact instance type as the node group.
Yeah, it doesn't
has
change
defined.
instance type, but Carpenter deals with different
Yes.
instances. I mean,
Yes.
with different instance types
Yep.
at the same time. Okay.
Yes.
Thanks.
So, yes, that's right. Because why this is important? Maybe a little story. What was the reason? And that's like a real horror story from like production deployment about Carpenter versus cluster autoscaler. So we had cluster autoscaler that was configured and was working like I just described, and then we were deploying new service, and it was like production service, so it had to scale up quickly. So there was like quite a lot of pod replicas, pod counts, and there were actually, I think, 3 services in this deployment. So there was quite a lot of new pods. And what cluster autoscaler did, it saw like there's a lot of pods, and added another instance and then another one, because there were still pending pods, and it was so slow that our deployment timed out at 10 minutes. So with 10 minutes was not enough for cluster autoscaler, or actually like the whole ecosystem with AWS behind that, to scale up cluster so the new service will be deployed. With Carpenter, you don't have that problem at all. Okay.
Okay, seems like this is all. Thank you, Adam, for your presentation. Thank you all for your questions.
Thank you.
And we have now a small break with drinks and snacks over there for our online viewers. We will be back in 10 to 20 minutes, and stay tuned with us.
thanks everyone for coming to our event. Thank you. My name is Anton Kovalenko. I'm solution architect at AWS. And today we will talk a bit about Amazon Code Catalyst and Amazon Code Whisperer. So agenda for today. So we will have two overviews of the products, Code Catalyst and Code Whisperer. Hopefully we will have demo. Hopefully it will work. You know, always live demo is a bit challenging thing. Workshop is optional thing. We won't do it today, but still we have it as a legacy point. So, and before we start, so asking an audience about what do you know about code family tools at AWS? So what tools do you know? Code commit. Code Whisperer, okay, good. Use it. Code deploy, code build. Okay, code pipeline, perfect. So, and this is actually the tools with the code prefix is a tools dedicated for developers, for developer agenda. So you need something to manage your CI/CD pipelines. You need something to manage your builds. Code commit is a repo, like Git compliant repo, and so on and so forth. But what is actually Code Catalyst? Let's start with that. And let's start with the questions which are coming to us when we are developing some application. So we're having, like, if we are looking a bit back to the in the history, how it was happening. Sometimes we had even no code repo stored it somewhere in the folder, in the, I don't know, in a shared folder. We had something like copied it in a versioning, like folder with a year, months, day, and so on and so forth. And release 1, release 2, release 3. Okay, now we're having repos. Also, about environments. We need to have something where we're testing our code, which is reflecting our actual prod environment. So we need someone, or maybe we will do it ourselves, creating the test environment, dev environment, before we're putting something to the prod. Also, management for the releases. What version of our code should go to the production? Also important question. Collaboration. When we're assigning the tickets, discussing what functionality we're introducing first, what functionality we're introducing next, and so on and so forth. And tool operations, application security, and so on and so forth. Actually, modern software development process requires a lot of tooling. So we all know that. Just remember how many tools you're using during the day. I don't know if you're in Atlassian stack, it might be Confluence, Jira, Bamboo. If you are in other stacks, it might be, I don't know, Jenkins, Asana, so on and so forth, GitLab. So lots of tools are used in a nowadays development process. An important thing here that those tools should not be should not work as individual chunks of functionality. We want them to be integrated. As an example, you're introducing a new feature. You are having separate branch in your repo. You are creating pull request. Maybe you want to map this pull request to the particular ticket you are having in your ticketing system. And maybe you are also want to map it to some knowledge base article in your Confluence or whatever tool you have for this. And for that, you are having several ways to do this. First of all, you can build your own solution. You can take various tools. You can build your own integration, and then go ahead, having as much flexibility as you want and as much as effort as you need to complete it. It might be a tool chain where you can, for example, have a tools from the market and integrate it on your own. Services suite, as an example, already told about Atlassian stack. So you may have Jira, Confluence, Bamboo, and Bitbucket, all integrated by vendor for you. And PaaS, when where you are having some opinionated set of tools, set of integrations, and you are using it as you go, and you don't need to configure it too much. And actually, Code Catalyst is standing somewhere here. It is PaaS for these purposes. So it is having all functionality you need in the software development process. So you can store your code there, build and test, deploy to environments you have, rather test dev or whatever. Make an operations. You can collaborate there. You can create there in different ways. So you can provide access to different team members with different permissions. You can also provide access to the planning, to the deployment, to the development, and so on and so forth. Project management and planning, so you can create tickets, you can manage these tickets, assign these tickets, prioritize these tickets as well. So it is a what we're calling unified software development system. So this is a Code Catalyst. So the benefits of the Code Catalyst. First of all is acceleration. Frankly, I'm using the Code Catalyst from even early access program, so it even before it was available generally. And I can say, yes, project can be established very fast. So you are just logging into the Code Catalyst, creating a space, creating the project, creating, I don't know, code repo. Voila, you are having a project. You can automate your workflows. Yes, workflows could be created easily. We will take a look at this during the demo. You can automate your environments. So yes, you can have different environments, and you can automate deployment to the different environments. And for example, you can have environments for your solution. You can have environments for development as well. So we can have development environments inside the Code Catalyst. And collaborate. Yeah, sure, you can invite other people to the Code Catalyst and work together on the same project. So what is accelerated project setup? So you can create project from the scratch. You can create project from predefined blueprint. And actually, also the good use for the blueprints, you can create projects from the blueprint to take from there some good hints on how to configure workflow, on how to configure repo, how to configure developer environment. So this is a good point for this. So blueprints. Blueprints is something which is available in Code Catalyst, and there are blueprints. Actually, what is important about blueprints? They're already well architected, so you can consider that what is done there, it is well architected, and you can use it for things like from web application to event-driven architecture, different things. So inviting you to take a look at that. And from automation perspective, you can create workflows. And workflows could be created either in programmatic way, using YAML files, or with a visual editor, where you can take some already predefined chunks of actions, like, I don't know, CDK deployment, CloudFormation deployment, like GitHub actions from the library, and reuse it in your automation, which is actually gives you like accelerated way to configure that. So from the perspective about dev environments, what is dev environment actually? Dev environment is a environment which is running inside the code catalyst, inside the perimeter, where you are having your IDE running, and you are connecting to this with an SSH. Like, for example, if you're using JetBrains, you can connect with the JetBrains gateway. If you're using VS Code, you're connecting with the SSH. Today I will show how it looks like from SSH gateway perspective. So, and there are plenty amount of benefits when you're doing this. One of the benefits, security. Your code is not leaving the perimeter. So you're not getting the code on your machine. Code is like cloned only to this machine, which is running inside code catalyst perimeter, in the same perimeter with the code repo. Another thing, you can standardize development environment. There is a standard for this, dev.io, and you can use it to configure these development environments, and your developers can run development environments from this template. So, and it will be configured in the same way. So, and it could be launched on demand. So when you need it, you use it. When you don't need it, you don't use it. And let's say not utilizing the hours of code catalyst. We will take a look at these hours when we will talk a bit about pricing. So the same thing about environments. Deployment environments is a environments when you are running your application. You can have, I don't know, test environment, dev environment, production environment, and for sure you can configure it with the infrastructure of the code. You can track it. You can track how you are changing your environment, and so on and so forth. So, and environments is also important piece of code catalyst. So you can decide, for example, in your workflow, if you are talking about automation, in what environment, with which permissions, with which options, with which variables you are deploying your application. So collaboration, yeah, you are having opportunity to collaborate. Everyone is having opportunity to see what is happening in the project. Important thing here, no AWS account needed. So to use Code Catalyst, actually you don't need AWS account. You need AWS account to deploy solutions. So in the end, you still need AWS account. But if you are inviting the teammates, they don't need AWS account to collaborate. They need the thing which is called Builder ID. I don't know, how many of you heard about Builder ID? No one. Okay, so I will explain. So Builder ID is something which you can create when you are registering, signing up for Code Catalyst or Code Whisperer, and it is not related to AWS account. It is just something you can do with your own email. It is free, you don't need to pay anything for it. It is just a Builder ID which you're using to log on to Code Catalyst or Code Whisperer. So also, team members can collaborate, track issues using Kanban, Scrum, other methodologies. It is available inside Code Catalyst as well. And actually the smooth integration between Code Catalyst and AWS. Interesting thing, yeah? Okay, so we are saying now that Code Catalyst is something different from AWS. And actually what I told you, that you are logging into Code Catalyst with Builder ID, and for AWS, you will need to connect your Code Catalyst space. We'll talk about spaces during the demo, to AWS account, which you want to use. It might be one account, it might be several accounts, which you want to use as two main use cases. So for the billing for the Code Catalyst and to deploy your environments. So, and actually also you can integrate existing tools like source repo, like GitHub, issue tracking systems, release automation, development environments, and actually lots and lots of things can be done, because actually under the hood you're using regular automation. For example, if you in a build systems, you're using regular automation, you can call whatever you want and do different stuff. Okay, so that was about Code Catalyst, and now we will talk a bit about Code Whisperer. Okay, who of you ever used any kind of code generation tools? Okay, what kind of tools? Copilot, ChatGPT, Copilot. Okay. Who ever used Code Whisperer? Oh, I'm a single person here. Okay. So let's take a look at the Code Whisperer as well. Maybe I will a bit change your mind on that. So, why actually we are using any kind of code generation tools, coding assistance, AI coding assistance, lots of terms at the moment. First of all, developers. Everyone is saying about shortage of developers, or developers. I wouldn't say about developers' time, because time is precious. Also, there is a thing which is called undifferentiated code. Maybe we don't want to spend too much time to reinvent, I don't know, Fibonacci sequence. And also, appropriate use of open source. We'll talk about it a bit later. Data privacy. Also, time to learn new technologies. How many frameworks are upcoming, for example, for JavaScript? Yeah, I see the pain. Okay, and also security, write secure code. So keeping code secure. What is Code Whisperer? Code Whisperer is a tool which is allowing you to generate real-time suggestions for the code using the. Actually, you are using comments. You are putting comment. Just imagine you are having code without comments, which is doing the stuff. And rather than that, you are having comments without a code. So I want this function to fetch message from SQS queue, and Code Whisperer doing it for you. Another capability is a scanning code for vulnerabilities. So also option for Code Whisperer. And important feature is a flagging the code which is fetched from some, which is very close to some open source samples, which could be considered as used under some particular license. We're calling it code reference. And if you using Code Whisperer and
agreeing on some particular suggestion, and this suggestion is coming under particular license, I don't know, my MIT license, Apache 2 license, and so on, Code Whisperer will return it to you. So it will say this piece of code is going under this license. Maybe it is violating some of your requirements. Maybe it's violating for some of your compliance. And you can take a look at that. So, how it works? Well, do I need to explain how this thing working at the moment? So, well, frankly, it is working like any AI assistant. It is sending the context to Code Whisperer and then returning back the suggestion. So, but it is also something to keep in mind. If it is violating somehow your guardrails, you need to keep it in mind. So if you need, for example, you don't want Code Whisperer to send requirements to send queries over internet. You may use, for example, things like VPC endpoints, interface endpoints. Yep. Yes. Another question, do you know if it is integrated with any other tools in AWS? Like SageMaker? Okay. Yeah, it is integrated with the Cloud9. It is integrated even with the Lambda editor. Okay, so there are 5 languages: Python, Java, JavaScript, TypeScript, C#, .NET, where you are having full function suggestions. Other languages are supporting inline suggestions, so it is code is suggested line by line, but it is also supported. Also, what about Cloud9? See here, we're having it even here. So VS Code, like we're having here PyCharm and IntelliJ, but as long as JetBrains is having the same base for all of their IDEs, it is supporting most of JetBrains IDEs. SageMaker, Studio, CLI, Golang, and so on and so forth. And like I said, SageMaker, Studio, Lambda editor as well. So, benefits we understand. Quickly coding some basic tasks. I already mentioned Fibonacci. Unfamiliar things, so you don't need to go and search Stack Overflow, suggestions, using your favorite tools. Under favorite tools, we're mentioning IDs, and improving security and using AI responsibly because we are having reference. So, 3 things: reference tracking, security scanning, and okay, bias avoidance. Who of you are familiar with the bias avoidance? What is bias? Okay, maybe a couple of words. Yeah, very close, but and actually it is something how the thing works, because it is trying to generate the code as general as possible for your particular use case. So this is an example, but we will go through the examples during the demo. I wouldn't spend too much time on that. Reference tracking, just suggesting you to use it. And important thing here, all of the capabilities are available if you are having builder ID and not using enterprise controls for free. So you can use Code Whisperer for free. You're just creating a builder ID, installing AWS Toolkit in your IDE, hopefully supported IDE for that. It might be a VS Code, it might be JetBrains IDE, other which are supporting AWS Toolkit, and you can use it for free and test it for free. Enterprise controls. Also, Code Whisperer having enterprise capabilities. It could be enabled for organization. And if you are enabling it for organization, you can put some policies there, like filtering on code suggestions. You're saying, I don't want to allow code suggestions with this particular reference. And that's it. So it won't work inside your organization if you are managing it. So, but from enterprise control, you need a Code Whisperer Professional, which is paid. It costs $19 for user per month, and it is having some particular limitations. Important thing here is this about data collection. It is guaranteed that AWS is not collecting your data, not storing your data, and not using your data to train model. Because actually it is one of the big concerns in the coding world. So, are you collecting my code? Are you collecting my requests? No, AWS is not collecting anything. You can configure it. Okay, about demo. So hopefully we have enough time for demo. Yeah, we have. Yep. Mm-hmm. Mm-hmm. Actually, when we take a look at how it looks, how it works, Code Whisperer gives you several options.
Which options accept licenses? Just list licenses. Which options does this tool provides? I mean, to select desirable or undesirable licenses. Maybe something else?
Well, actually, it suggests you different versions. For example, if you're asking for the function, different versions of the function, and you may select.
I have a related question. Suppose I unselect all the licenses and similar options. What kind of suggestions will remain? That's a tricky question, I guess.
Yeah, questions are tricky, but and let's keep in mind that this is a generative model, which is actually putting token after token, and it will still keep trying to build what you.
It's a model. It's a model generating model. I mean, is it? Does it just get solutions, existing solutions, and provides to you, or it's really generating?
It generates.
Say,
Is it
able to provide something really new?
Oh, this question is
understand.
tricky. I would suggest you to try.
Okay, I've got it. And about authoring, which let's say author rights we can use with this generated code? Can we let's say claim the right for this code which is suggested?
Anyway, this code, when you are actually you are responsible for this code,
right?
So you are, and also you are owner of this code.
Okay.
So no one except you. It is just like assistant, which is giving you example, which you can reuse.
You did mention references. Which are the parts of this reference? Only license type or something else?
A license type.
Only.
As far as I remember, yes, but I can check.
It's again about authoring. Suppose the author doesn't give the rights.
It is also giving you reference to the repo.
Oh, okay, that's enough.
Similar to where it goes from.
Yeah, thanks.
Okay. And we're now going to the demo. I just wanted to show what we will use to try our code catalyst. It is pretty much straightforward microservice. And let's imagine that we're having big system, I don't know, purchasing system, response system, whatever, where people are allowed to upload pictures. And we know that people can upload anything they want. And we don't want to some inappropriate picture to appear in our system. And for this reason, we're having this small microservice. And actually, it is reacting on uploaded picture. It is invoking Lambda function, which is just sending a job to the SQS queue with information about newly uploaded image. Then we're having service which is running inside the container in Elastic Container Services, which is taking this image and checking this image with recognition. And now we're taking not just labels for this image, but we're taking moderation labels. So moderation labels means if we're having anything inappropriate there, I don't know, tobacco, alcohol, nudity, whatever, and putting it to DynamoDB. And other services can reuse this data to make a decision if we are publishing this image or not. So what we are having already in place, our solution is deployed. We are having this service, but we will take a look how we can create this service with the Code Whisperer. Just a disclaimer. And also we want to, we are not having any automation at the moment to react on on the picture upload. And we want to deploy it also. And we want to use Code Catalyst for it. So